This situation is emotionally charged, and it's on the verge of a dramatic event. There's no certainty about the exact timing of what's coming. It could happen tomorrow or perhaps even during this transmission. The event will be striking, like a glowing second sun. Recently, the James Webb Space Telescope discovered a surprising 250% increase in the brightness of Betelgeuse, the red giant star located at the shoulder of the Orion constellation. This unexpected behavior has sparked significant interest and curiosity. Some speculate that this sudden increase in luminosity may signal that Betelgeuse is gearing up to explode in a supernova, but the exact timing of this remains uncertain. Experts believe the event could occur sooner than expected. Join us as we delve into the depths of space and uncover the mysteries surrounding this colossal star, a discovery that could drastically alter our understanding of the cosmos. Despite the unfamiliarity of its name, you've likely admired the brilliance of Betelgeuse, a vivid, bronze-colored glow shining brightly at Orion's shoulder as part of a well-known star cluster. Its enormity is staggering. If placed at the center of our solar system, its outer layer would stretch far beyond Jupiter's orbit. This colossal star continues to captivate observers, and unlike most stars, Betelgeuse exhibits noticeable fluctuations in its behavior over time. Due to its proximity to our system, Betelgeuse is classified as a semi-regular variable star. Its brightness fluctuates predictably, hinting at an eventual breakdown that might lead to a cosmic explosion. Recently, Betelgeuse has become even brighter due to remarkable shifts in its luminosity. Among these fluctuations was a dramatic increase on May 20, 2023, when scientists recorded a 142% rise in brightness, followed by a later update confirming a 150% increase. Astrophysicists from the Harvard-Smithsonian Center for Astrophysics pointed out that Betelgeuse has now become the seventh brightest star in the night sky, climbing 3 positions from its usual 10th place. From the southern hemisphere, the star shines visibly in the night sky, a stunning sight at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist at Swinburne University of Technology in Australia, emphasizes the importance of studying Betelgeuse, as it offers a unique opportunity to examine the final stage of a massive star's life cycle, shedding valuable light on the behavior of red giants before they explode as supernovae. When Betelgeuse does eventually explode, it could become exceptionally bright for around a week, possibly casting shadows at night. This possibility has both amateur astronomers and professional space scientists eagerly anticipating the event. Heidi Morris, a scientist at Los Alamos National Laboratory and the president of the Pedro Stargazers and Cosmology Club, observes that the consistent interest in Betelgeuse's brightness variations is a phenomenon that has intrigued multiple cultures for many years. Currently, Betelgeuse's brightness cycle spans about 130 days, much shorter than its typical multi-year cycle, making these rapid changes a rare opportunity for astronomers to study the stellar anomaly in greater detail, offering unprecedented insight into the last phases of a star's existence. The erratic behavior of Betelgeuse began in 2019 when the star suddenly ejected a portion of its outer atmosphere. These variations in brightness are unusual, leading to questions about whether it is nearing its end and may explode into a supernova. According to a study authored by Dupree and other researchers from Harvard and the University of California, Berkeley, it may take another 5 to 10 years for Betelgeuse to return to its expected 400-day brightness cycle. Since the star has displayed unusual behavior in both its light and rotation speed, astronomers are left wondering whether these fluctuations are the beginning of the end for this massive red supergiant. Betelgeuse is indeed a massive star nearing the end of its life, exhausting its fuel and entering a phase of rapid evolution. As its core collapses under its own immense mass, it could trigger a supernova explosion powerful enough to overshadow entire planets. However, the precise timing of this event remains uncertain. Dr. Pierre, a professor of cosmology at the University of Portsmouth, notes that predicting the timing of a supernova remains challenging due to the lack of comprehensive historical data and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes, constantly evolving by fusing elements like helium, carbon, oxygen, silicon, and eventually iron. As a red giant star, it converts helium into carbon at its core, a process that takes millions of years. Eventually, it will begin to fuse heavier elements until it reaches a point where it can no longer support fusion reactions, leading to a gravitational collapse and possibly forming a black hole or a neutron star. While some theorists predict that Betelgeuse's explosion is imminent, historical data suggests that the star has been gradually growing redder over the years, implying that it could take a significant amount of time before reaching the supernova stage. NASA estimates indicate that Betelgeuse isn't expected to explode for another 100,000 years, offering reassurance that it is unlikely to happen within our lifetimes. Despite the uncertainty surrounding its exact future, the unpredictable nature of Betelgeuse's behavior continues to captivate scientists. Advancements in our understanding of stellar evolution are still ongoing. Dr. Sarah Webb reminds us to remain open to all possibilities. Even as the chances of witnessing Betelgeuse's explosion in our lifetime seem remote, tracking its changes could lead to further scientific breakthroughs. It is important to keep in mind that our observations of Betelgeuse are essentially witnessing the past. The light we see from the star is over 600 years old, meaning Betelgeuse may have already exploded, and we wouldn't yet know it. Although this is a possibility, it is far from certain. History has shown that our assumptions in astronomy can be challenged. For instance, prior to 1987, astronomers believed that only red supergiants could go supernova. However, that year, a massive blue star in another galaxy exploded, surprising the entire academic community. This proves that there is still much to learn, and surprises may be ahead. Observing Betelgeuse and other massive stars provides an opportunity to expand our understanding of celestial phenomena. Even if the explosion is not imminent, the star's unpredictable behavior is still fascinating and reveals important aspects of stellar physics. Betelgeuse's increased brightness in 2023 has reignited global excitement, sparking renewed interest in this astronomical giant. Some astronomers believe that the current surge in brightness is a sign that Betelgeuse is nearing the end of its life, while others caution that it might simply be undergoing an unusual but typical phase of evolution. Regardless of the cause, these fluctuations offer a thrilling chance to observe stellar behavior in real time, giving astronomers and stargazers an opportunity to test hypotheses about the life cycle of massive stars and their eventual demise. As we continue to watch Betelgeuse, it serves as a reminder of the ever-changing and mysterious nature of the cosmos. Whether it is dimming or brightening, its dramatic shifts offer a rare opportunity to observe the intricacies of stellar evolution firsthand. For astronomers and stargazers alike, the story of Betelgeuse is far from over. With each new observation, we move one step closer to unlocking the mysteries of the stars. The watchful gaze on Betelgeuse. As the world's most powerful telescopes remained locked onto Betelgeuse, astronomers eagerly awaited the next twist in the star's unpredictable behavior. Observatories from every corner of the globe, from Chile's Atacama Desert to the frozen plains of Antarctica, monitored the red supergiant's fluctuating brightness, hoping to capture the first signs of its inevitable transformation. Then, one night, something extraordinary happened. The sudden shift. On a crisp winter evening, deep within the archives of the European Southern Observatory, astrophysicist Dr. Elias Varga noticed an anomaly. Betelgeuse, which had been brightening for months, suddenly dimmed, this time, far more drastically than before. Within hours, reports from other observatories confirmed the finding. The once brilliant star, a beacon in Orion's shoulder, had faded to half its usual luminosity. Speculation ran wild. Was this just another phase of Betelgeuse's erratic cycle, or was it the first real sign that the star was collapsing in on itself? As the news spread across scientific communities, amateur astronomers and stargazers across the world turned their telescopes skyward. Social media erupted with excitement. Would they soon witness a celestial event unseen by human eyes for centuries, a supernova unfolding in real time? A race against time. NASA and the European Space Agency, ESA, redirected their most advanced instruments toward the dying giant. The Hubble Space Telescope, the James Webb Space Telescope, and even the Chandra X-ray Observatory were tasked with recording every second of Betelgeuse's transformation. Dr. Helen Carter, an astrophysicist at Caltech, addressed the global media. We've seen Betelgeuse behave unpredictably before, but this level of dimming is unprecedented. If this is the precursor to a supernova, we're about to witness one of the most spectacular cosmic events in human history. But there was a problem. Betelgeuse was over 600 light-years away. If it had already gone supernova, the explosion had happened centuries ago, its light only now reaching Earth. That meant humanity was watching history unfold from the past. The final countdown. Over the next 48 hours, Betelgeuse's luminosity fluctuated wildly. It pulsed in strange, uneven bursts, as if struggling against its own fate. Radio waves and X-ray emissions from the star intensified. Some researchers believed this was the moment when Betelgeuse's core was collapsing, a process that would trigger the final, dramatic explosion. Then, just as quickly as the dimming had begun, Betelgeuse did something no one expected. It flared. A massive surge of energy erupted from the star's surface, brightening it to levels never recorded before. For a brief moment, Betelgeuse outshone every star in the night sky except for Sirius. It was as if the dying giant was resisting its own demise, burning brighter than ever in one final, defiant outburst. The world held its breath. The supernova era begins. On the morning of March 3, 2026, at exactly 4:17 Universal Time Coordinated, Betelgeuse exploded. The detonation sent a shockwave of light and energy across the cosmos. 4 days, Earth's night sky was transformed. The explosion was so bright that it rivaled the full moon, casting eerie shadows even in the dead of night. Stargazers across the planet stood in awe, watching history unfold in real time. For astronomers, the event provided an unprecedented opportunity. Never before had a supernova been observed this closely, in such detail. Data flooded in from every corner of the world, helping scientists refine their understanding of stellar death and cosmic evolution. But the explosion wasn't just a moment for science, it was a moment for humanity. For the first time, people everywhere looked up at the sky and felt the immensity of the universe, realizing that even the most brilliant stars must eventually fade. A new beginning. As the afterglow of Betelgeuse's explosion slowly faded, something remarkable took its place. At the heart of the debris field, where the mighty star had once shone, astronomers detected the birth of a neutron star, a remnant of the massive explosion. The cosmos had reclaimed Betelgeuse, reshaping it into something new. And in the process, it had gifted humanity a once-in-a-lifetime experience, one that would be studied, written about, and remembered for generations to come. Betelgeuse was gone, but its legacy would shine forever. The echo of a supernova. As the explosion of Betelgeuse rippled across the universe, astronomers scrambled to analyze the aftermath. The colossal burst of energy sent waves of gamma radiation, X-rays, and neutrinos racing toward Earth. While our planet was too far away to be harmed by the explosion, the event illuminated vast stretches of interstellar space, revealing hidden celestial structures previously obscured by dust. But the supernova was not just a scientific spectacle, it was a moment that changed how humanity viewed the cosmos. The night that turned to day. 4 weeks, Earth's night sky remained transformed. The remnants of Betelgeuse glowed so intensely that cities around the world reported unusual atmospheric effects. In rural areas, people could read books by its eerie, bluish-white light. Some described it as a second moon, while others called it a celestial beacon marking the death of a giant. Religious leaders, philosophers, and artists found new inspiration in the event. In many cultures, the supernova was interpreted as an omen, a cosmic reminder of the universe's impermanence. Meanwhile, poets and songwriters captured the beauty of Betelgeuse's final blaze in stories and melodies that echoed across the internet. But amid the wonder and awe, scientists were racing against time. A black hole or a neutron star? Telescopes around the world focused their lenses on Orion's shoulder, where Betelgeuse had once shone. The explosion had left behind a dense core, but what remained was still unclear. Would it collapse into a black hole, or had it become a neutron star, a rapidly spinning remnant with unimaginable density? NASA's Chandra X-ray Observatory and the European Space Agency's XMM Newton telescope scanned the region for answers. Within days, astronomers detected a rapidly pulsing source of X-rays, a clear sign that Betelgeuse had become a pulsar, a neutron star spinning hundreds of times per second, sending beams of electromagnetic radiation sweeping across the galaxy like a cosmic lighthouse. The discovery was groundbreaking. A pulsar this close to Earth had never been observed in such detail before. With every rotation, Betelgeuse's neutron star sent out radio signals that could be picked up by observatories across the planet. For scientists, it was a treasure trove of data, a new laboratory in the sky to study gravity, magnetism, and the nature of matter under extreme conditions. And then, something even stranger happened. The cosmic message. On April 17, 2026, a month after the explosion, the world's largest radio telescopes detected an unusual pattern in the signals coming from the Betelgeuse pulsar. At first, it seemed like ordinary pulses, steady, rhythmic, predictable. But as astrophysicists analyzed the data, they found irregularities. The signals weren't just pulses. They carried structure, anomalies that seemed almost deliberate. Mathematicians and cryptographers were called in to decode the mystery. Some dismissed it as a natural phenomenon, a trick of physics. But others whispered the unthinkable. Could this be a message? Was the dying star, in its final moments, revealing something deeper, something hidden within the very fabric of the cosmos? As the world watched, waiting for answers, one thing became clear: Betelgeuse's story wasn't over. It had only just begun.